students. Previously, 30 to 40 years back, that is during 1980s and 1990s, that is during the childhood days of your parents, there is no power, especially in the villages. They used to spend the nights without power. That is, they used to spend the night with the help of candles. They don't have fans, but nowadays we are enjoying this power. We are having fans, we are having lights, we don't know which is day and which is night. We are also using ACs, and we have lot of comforts today because of the power. So today, in today's class, I'm going to explain you how to generate the power. What are different methods of power generation? So first one is different methods of power generation. Mostly there are three methods of power generation. First one is from water. Power will be generated from water. If such case, if power is generated from water, then it is called hydropower plant. The plant in which power is generated from water is called hydropower plant, and this hydropower plant will account for 30% of the total power generation in the state. Out of total power, 30% of the state's power is generated from hydropower plant. And second method to generate power is from steam. And under the steam, we have two methods. One is conventional method of steam generation, that is, first one is coal. Well, we know that coal is a fuel. When we burn coal, it will generate lot of heat. Because of this heat, we will convert water into steam, and because of this steam, power will be generated. And second method is nuclear reaction. We know that there will be two types of nuclear reactions. One is nuclear fusion reaction and other one is nuclear fission reaction. Nuclear fusion reaction will takes place in stars like sun, but here in order to generate power we will use nuclear fission reaction. It means one helium atom will be divided into two hydrogen atoms. In this process, in this nuclear fission reaction, in this process there will be lot of heat generation, and we will use this heat generation to convert water into steam. So these two methods will utilize to generate the steam, and this steam will be used finally to generate power. So from steam generation, this steam generation will contribute around 60% of the total state's power generation. So out of total power, around 60% of the power is generated from the steam. And third method to generate power is from wind. From wind, around 10% of the total power, out of total power in the state Andhra Pradesh state, out of total power, around 10% of the power is generated from the wind. Okay. Now in this video, I am going to explain you first two methods, that is how power will be generated from water and how power will be generated from the steam. So in order to explain you practically, I just made a small working model of hydropower plant. This is a small working model of hydropower plant. In hydropower plant, first what we will do is we will build a tank at very greater height. In hydropower plant, a tank will be there which stores water at very greater height. And when you release water from this tank, water with high pressure and high velocity from the tank, water will come out with high pressure and high velocity, and it will fall on this turbine. So this is called as turbine, water turbine. So when water falls on this turbine with high pressure and high velocity, this turbine will rotate with very high speed. So when this turbine is rotated with very high speed, this turbine will be connected to the generator. And when turbine rotates, automatically generator rotates. So when generator rotates, then power will be generated. Now let me show you this practically. So here I'm taking water in a small bottle, and I'm pouring this water in a tank which is at very greater height. So this tank, if you see, this tank is at greater height. So when I pour water in this tank, this water will release with high pressure and high velocity because of its height. Since it is at greater height, from the tank water will be released with high pressure and high velocity, and when it falls on this turbine will get rotated, and when turbine rotated, it will be connected to the generator, and in the generator armature will be rotated. When armature rotates, then automatically power will be generated. So here I am pouring water. So here you can see turbine is rotating with high speed, and when turbine is rotating, here in the ammeter you can notice the current generated. That is, in the ammeter, when turbine is rotated, current is generated. And you can collect this water again from the bottom of the turbine. Again you can collect the water. Again, now notice the changes in the ammeter when turbine rotates. So when turbine rotates, you can see that in the ammeter current is generated, and it is around 150 microamperes when turbine is rotated. And when turbine stops, slowly this current in the ammeter, it will show 0. So when there is no rotation of the turbine, current is 0. So when turbine rotates, then armature in the generator rotates and current will be produced. Now second method to generate power is from the steam. So from the steam we will generate the power. Now in this video I am going to show you how power will be generated from nuclear reactor. That is, by using nuclear reaction, how steam will be generated. This is a small static model that I prepared to show you how power will be generated from the steam. So here this is called a nuclear reactor chamber. In this nuclear reactor chamber, nuclear reaction takes place, that is especially nuclear fission reaction. It means one helium atom will undergo nuclear fission, and it will be divided into two hydrogen atoms, and in this process lot of heat energy will be generated. This lot of heat energy will be transferred to this chamber. This chamber is called as boiler. In this chamber water will be present, and when we supply heat energy, this water will be converted into steam. So this is called as boiler, where water is converted into steam. Steam will be generated in this boiler, and this steam will be transferred to this chamber through this pipe. In this chamber, pressure of the steam increases, and when pressure of the steam increases, steam will be passed on to the turbine. In this chamber there will be a turbine, and when steam is injected onto the turbine, then turbine rotates, and when turbine rotates, then armature in the generator will be rotated. When armature in the generator will be rotated, then power will be generated. So our main intention is to generate the armature, to generate the power. In order to generate the power, our main intention is to rotate the armature in the generator. So this rotation of the armature in the generator is achieved by different methods. That is, first one is by using water turbine, we are rotating the armature inside the generator. Second one is by using steam, we are rotating the armature inside the generator. And third one is by using wind, we are rotating the armature inside the generator. So when the steam is injected onto the turbine here, this turbine will be rotated, and automatically when turbine is rotated, here you can see a small LED glowing. So when turbine is rotated, power will be generated. Here you can observe a small LED glowing, and in this you can observe, in this voltmeter you can observe the voltage generated when turbine is rotating. Here when turbine is rotating, you can observe a voltage generated in this small voltmeter. So and you can also observe a LED glowing here, small LED which is glowing here when turbine is rotated. So from this we learned that, so in order to generate the power, from this we learned that in order to generate the power, our main intention is to rotate the armature inside the generator. Now when we rotate the armature inside the generator, then automatically power will be generated. So how this power is generated? What happens when we rotate the armature inside the generator? What happens? Now we are going to see that generator. So in 10th class physics, finally very important question you have is how generator works. Yes, now we are going to see that how generator works.